We are concentrating much on the continuity of functions in this video. Okay. I should be audible enough. Question 5 reads, of course, this is 1120 sheet 9. Question 5, evaluate the following limits. If they exist. A, f of x is equal to 15 if x is less than -4, and it's equal to 6 minus 2x if x is greater or equal to -4. So if here we are told we must do this limit as x approaches -4, we must find this limit here. As x approaches -4. So -4 is at the boundary of these two functions. So what we do is we'll have to find the limit as x goes to -4 from left of the function f of x. Now, the limit gotten in the left direction, you use the function when x is less than. When x is less than. So pick the function 15. But the limit of a constant function, remember we agreed that it will be a constant function. And then the second one, we get the limit as x goes to -4 from right. There we get when x is greater. So you get the function 6 minus 2x. Then substitute where there's x, the number -4. And so we'll have 6 plus 8, which is equal to 14. Well, for this limit to exist, we require that the side limits, this 15 was supposed to be equal to 14. Now that these two numbers are not equal, then the limit as x goes to -4 of the function f does not exist. Because, but if you have solved this, there's nothing like because you have already shown why you are saying like that. The two side limits are not equal. Okay. Another one, B, we are given f of t as g of t. We are given g of t is equal to t squared minus t to the power 3 for t less than 2. We also have 5t minus 14 when t is greater or equal to 2. So we're supposed to find the limit as t goes to 2 of the function g. So again, because 2 is sitting on the boundary, we need to find the limit as t goes to 2 from left. When we say left, we mean when t is less. So when t is less, we pick this. So we pick t squared minus t3. So we substitute where there's t, we put 2. So we have 2 squared minus 2, 3, which is 4 minus 8, which is minus 4. We also pick the limit as t goes to 2 from right of when, so from right we pick when t is greater or equal to, which is 5t minus 14, which is 5 by 2 minus 14, which is 10 minus 14, which is negative 4. When the two side limits are equal, it's telling us that the limit as t goes to 2 of g of t is actually equal to negative 4. So it exists and if t is equal to negative 4. Questions? I'm not yet asking here. Okay. Question 6. Evaluate the following limits. Again, if they exist. For A, the limit as x goes to 4 of 9 plus 8 minus 2x. Like that. So, or if I'm given this kind of a function, though I know the absolute value, when I have the absolute value, I'm supposed to redefine and get rid of the absolute. So I do 8 minus 2x. If 8 minus 2x is greater or equal to 0, I also do minus 8 minus 2x. If this is less than, if this is less than 0. But looking at the nature of the function, The absolute is just, it's not multiplying by a number and it's not being divided by a number. So I can as well just substitute direct. So get 9 plus 8 minus 2 multiplied by 4, giving us 9 plus 8 minus 8, which is 9 plus 0, which is just 9. So that's how we get that there. But we don't do that for every function. Look at what's happening when you have a fraction. This guy over h, as h goes to 0. Well, we know that when you redefine this, we have h when h is greater or equal to 0, and we have minus h when h is less than 0. So when we come here, it means that we have to find the limit from two directions. When h is less than, that is from left. And so we have minus h on top over h down. And this is giving us a limit as h goes to 0 from left, minus h over h, that is just minus 1. And the limit of a constant is just a constant. And then we come back and get the limit as h goes to 0 from right, that is when h is greater or equal to. So we'll have h over h, the positive h, giving us 1. And so this is going to be 1. And so because the two side limits are not equal, so we're saying the limit, therefore, as h goes to 0 of the general function does not exist. Like that.
So,
Hello.
like in the first case, now how do you know if the function has the limit?
Well, when there's no division or multiplication, we just do once. We just substitute direct, because even if I had to get the pieces, if we say let's get the limit, as x goes to 4 from left, I would have had 9 plus, mean 9 minus, would have picked the minus of this. So we say minus 8 minus 2x. Then you substitute 4 here. You would get 9 minus 8 minus 2 by 4. This is 0, so you just get 9. And then if we said now let's get from right, we have 9 plus 8 minus 2x. I would still get 9 plus 0, which is 9. So most when it is standing alone like that. But anyway, the best is to be checking on the side. Because depending on the side, you may get a different value. So this is the recommended one. Yes. So we look at C.
The limit exists. We don't conclude by saying that the limit exists.
When the limit exists, No, we don't conclude because it's visible. We just write it. So I've said the limit at x goes to 4, we write it. Here we said, because these two are equal, we wrote the limit here. When you write it, it means it exists.
All right.
The limit as x goes to 4 of x minus 4 over x squared minus 16. So here, we first write the limit as x goes to 4. We maintain that, and then the denominator, we use a difference of 2 squares to write it like that. Well, we're doing this because we know that when we go up, this one here has two definitions. X minus 4 when x minus 4 is greater or equal to 0, and minus x minus 4 when x minus 4 is less than 0. So this is happening around 4, x minus 4 when x is greater or equal to 4, and minus x minus 4 when x is less than 4. So when we come here, it's telling us that we have to get two side limits. The first, the limit as x goes to 4 from left of the function f, which is, so we pick this part. When you say from left, we are picking where it is less. So we pick minus x minus 4 over x minus 4, and then x plus 4. So that this piece and this piece can cancel. Then we'll have the limit as x goes to 4 from left of minus 1 over x plus 4. Then substitute where there's x here, we put 4. We get negative 1 over 4 plus 4, which is negative 1 over 8. And then the second one will be the limit as x goes to 4 from right. The numerator now, so when we say from right, we are picking where x is greater. X minus 4 over x minus 4 multiplied by x plus 4. So this and this will get the limit as x goes to 4 of 1 over x plus 4. Substitute, we have this, which is 1 over 8. And again, because the two numbers are not equal, so we say therefore, the limit as x goes to 4 of the whole function, which you can write as of the function x minus 4 over x squared minus 16 does not exist. Okay. We now go to question 7. The first one, the question say evaluate the limits again. Evaluate the limits. That is, for A, if you're given g of x is negative 4 over x minus 1, squared. So here, what you do is we want to get the limit as x goes to 1 from left of g. We're also asked to find the limit as x goes to 1 from right of g. And then we have to find, so this is 1, this is 2. And then the third is that we should find the limit as x goes to 1 of g of x. So what we do is, if you try to substitute 1 there, suppose you try to substitute 1, you would get this -4 over x minus 1 squared. It's going to be -4 over 0, which is undefined. Now we don't want the undefined. So as we search for this limit, the easiest way would be to sketch the function. When we sketch the function, this is a fraction. So you find the vertical asymptote, which is equate the denominator to 0, which means x minus 1 is 0, so x is equal to 1. And so 1 is the vertical asymptote, like this. So when 1 is a vertical asymptote, then there was not asymptote once the numerator has parallel in the denominator. It's the x-axis. So I pick a number bigger than 1, say 2, and substitute it in g. So what is g of 2? We'll have -4 over 2 minus 1 squared, which is -4 over 1, which is -4. So the number is negative, so the graph is going to be coming down like that. Then from left, if we pick 0, we'll have g of 0 to be -4 over 0 minus 1 squared, giving us -4 over -1 squared. But -1 squared is +1, so we get -4. So again, this is telling us that this graph is down here. We're getting -4 at the intercept, but it's going down. So either direction, the limit here is -infinity. And also from right is -infinity. This means that the general limit is -infinity because the two are equal. The two side limits are equal. So whenever I'm given a question like this where I can't simplify for me to get the limit, I can't do anything to avoid the 0 part. So you will have to have an option but to sketch the graph and then analyze the sketch. That will be the only way. Okay. Another one. So do C now. F of x is equal to x minus 1 over x squared minus 9 to the power 4. So every time I have a fraction, I get the denominator to 0. So this means x minus 9 is 0. So x is plus or minus 3. You only differentiate the numerator and the denominator if you get 0 over 0. But for the other one, you had 4 over 0. So it can't work. So when we sketch, we have -3 and +3 as the asymptote. Then the vertical, the horizontal, you look at the powers of x, so you get the x-axis. Like that. Then now sketch. After 3, we can pick a number like 4. Substitute here. We have f of 4 is 4 minus 1 over 4 squared, which is 16 minus 9, and then to the power 4. That's 3 over 16 minus 9, that's 7. So 7 power 4 is positive. So we are putting this up there. But then every time I have the variable in the numerator, I get the numerator and equate it to the horizontal asymptote, which is 0 in this case. So we get x is equal to 1. So on that region, we've seen that we're getting a number that is positive, so it's above there. Then in between here, we have gotten 1. So this graph is going to cut at 1. Okay. Then we check what is happening at, let's say, 2. At 2, we have 2 minus 1 over 2 squared minus 9 to the power 4. That is 1 over 4 minus 9, that's minus 5. Minus 5 power 4 is positive. So the graph is coming from up in this region. Now let's see what is happening at 0. We have minus 1 over 0 minus 9 to the power 4. That is minus 1 over 81 by 81. What does that mean? The number is negative. So it means that we have a curve of this nature in between here. And then we pick from left. Let's pick -4. We substitute f of -4 is giving us -4 minus 1 over -4 squared, that's 16 minus 9 squared. So this is going to be -5 over 7, 4. That's 4, which is a negative number. So this graph is coming like this. So the question is about, we are supposed to check as x approaches 3 from left. So I'm looking for the limit as x approaches 3 from left of f. So from left, we're talking of these 3 here, So from left, you are coming in this direction using this curve. So it's going to positive infinity. And then from right, of f. We're talking of this one. So that's positive infinity. So because the two are equal, we have the limit as x goes to 3 of f to be equal to positive infinity. Like that. So an exercise. Solve question 7, B and D. And question 9. Question 9, A, B, and then we'll come and do C and D after you have submitted. You also solve question 8. Question 8, A and E. So tomorrow we'll have a session, and I want the solutions submitted before the session for tomorrow. But if you don't submit, you even know you can't ask about the class because you have an exercise to do. So Tionji, I'll comment on, I saw your message, I'll comment tomorrow as we wind up this tutorial sheet tomorrow. And possibly we'll start tutorial sheet 10. So for now, this is where we end. Bye-bye.
Ask on the previous video, the previous class video.
Previous class video,
Yes,
they should be here in the group, I think.
I just joined today.
Okay, so we'll post them.
Thank you.